Hey guys, this is Miss Latours. We're over here at the Mount Juliet Library. We're going to do the next part in our astronomy series, which means that Saturn is up today. Now, Saturn is a Jovian planet. What that means is that it's ridiculously large. Only Jupiter is bigger than that. It's got lots of moons. In fact, it has a total of 82 moons that we know of. It's an outie, meaning that it's very far away from the sun. It's about 890 million miles away, or about 9.6 AUs. It has a very fast rotation. One complete rotation only takes 10 hours, but because of the distance away from the sun, one revolution, or 1 year, takes a total of 29 Earth years. It has very low density. The average density of Saturn is about 0.7 grams per cubic centimeter. Just to give you an idea, the average density of water is about 1.0 grams per cubic centimeter. That means if we could find the world's biggest bathtub and drop Saturn in the middle of it, Saturn would actually float. But then again, it would leave a ring around it. Really? Nothing? Hello? Is this working? Oh, fine. Let's just move along. After Galileo invented the telescope, he looked at Jupiter. We told you that story. He then also saw the rings around Saturn. As it turns out, all of the Jovian planets are going to have rings. The ring around Saturn is created as a result of something that we call the Roche limit, meaning something got too close to the surface of Saturn and it literally got crushed by its gravitational pull, and that's going to generate the rings around it. When I was a kid and the dinosaurs wandered planet Earth, we thought that Saturn only had 3 rings. Take a look at this. You think we've come a long way in our understanding of how things work in space? Here are the other rings. We've got the rings of Jupiter, the rings of Uranus, and the rings of Neptune. All of them are completely different because they each formed in a different manner. What really makes Saturn interesting is Titan. No, not that Titan, but rather the moon Titan. In 1655, a Dutch astronomer named Christian Huygens is going to actually discover it. What makes Titan so incredibly interesting is that there is a very real possibility that life is going to evolve on the surface of Titan. The factors that triggered life over here on planet Earth also exist over there on the surface of Titan. For example, it's got the combination of organic compounds that we found in our atmosphere as well. These organic compounds could trigger the chemical reaction that's going to be necessary to actually create life on Titan. When we first went into deep space by way of Voyager, we were so interested that when Voyager was done with Saturn, it zipped over, took a detour around at Titan, and as it turns out, we didn't find any life. 30-something years later, though, we would launch another space probe called the Cassini-Huygens, and that's going to cause us to rethink whether or not life is going to exist on Titan. Because what they found happening on Titan, as well as another moon that we call Enceladus, is they found the existence of water. But that water came into existence as a result of something that we call cryovolcanoes. A cryovolcano is like a regular volcano, but instead of spitting out lava and magma, it's going to spit out ice crystals. This ice crystal is going to become the basis of water that's going to make it possible for life to evolve on the surface of Titan. One genius once said, every time we answer one question, we develop 10 more. Our exploration of deep space is an example of what's happening over there. So much so that in the year 2019, President Trump created the United States Space Force. I wish I was going to be around here for another 20 or 30 years to see what we find as a result of that exploration. But you guys are going to be there. Lucky you.